Okay, now discussing one of chapter in based upon the physics. In the chapter, as they ask as a in our based upon the concept. In daily life, we can see different applications for use in light chapter. We discuss different properties and different applications also. So in this chapter, they ask as a the main property of light is light contains so many property. First of all, we discuss in this chapter light. Light is a one of energy. They coming from any luminous object. Here things we can observe is a different pattern. They will be here. The materials are three types. First one is a transparent, means they will be easily pass off light. They will easily pass off light. It's called transparent. It's glass, mirrors, lens, and so on. This is called transparent. Translucent means light is passed, but very small amount will be passed. It's called translucent. This example is called as a oil papers. Third one is a opaque object, means light is cannot pass. So this is a plastic, this is a polymer, it is a opaque object. So this is a not pass of electricity. In our human body is a opaque object because in our human body they cannot pass off light. In the same way here we can see daily life so many. In this theorem, Newton is explained some type of postulates that regard as a first one is a light is a light is required any medium to propagation. This is first postulate. They can be given by the one of scientist Newton. Propagation. So this is first scientist. They can explain the property of light. First one explain the light is required to any medium to propagation. First condition. Condition number 2. In case of denser medium is in denser medium is more than the velocity of light. Second condition, it will explain the velocity of light in denser medium is more than the rarer medium. This is a second condition we can explain. Okay, in case of Newton, they can explain the property of light is that the velocity of light is more than denser medium. Then it's more in denser medium, less in rarer medium. Third condition given us here, light is pass on a particle nature. Light is progress, simply call it pass. Simply propagation is particle nature. So this in medium will be particle nature. So this type of nature we can give the information. So light can be passed on a particle nature. First scientist, so this is the first scientist to give the information about some type of postulates. They can explain the light by Newton is a first principle will be here. Light is required to any medium to propagation. So this is a first condition, the rarer medium. The velocity of light is maximum in denser medium and minimum in rarer medium. For example, we can observe. Okay, in case of water, is more in air. The velocity of light is more in water, less in air, according to Newton theorem. So in case of here, water is a denser medium, air is a rarer medium. So the velocity of light is more in denser medium, less in rarer medium. So this is a second condition. Third condition we give given here, the light is a propagation. The propagation of light is any medium by in particle nature. In particle nature. So this is contained. This type of particle nature they will done also. So the velocity of light is a medium by particle nature. So the light is propagation in medium by particle nature. propagation in particle nature. Okay, particle nature, like this type of nature we can explain the Newton theorem. So this is called as simply called as a Newton's theorem. Second theorem, we can give the some type of information about give the second theorem will be here Huygens theorem. So this is a first theorem. Okay, this simply called as a Newton's theory of light. Simply called as a Newton's theory of light. This simply called a particle nature of the light. So simply called as a particle nature of the light. The particle means so this type of particles we can observe this type of pattern also. So this is the first theorem they can explain by the Newtons by regard as a light. Second theorem will be here. Okay, Huygens theorem. This is a second theorem they can give us. Okay, second scientist we can give some regard as a data, regard as a light. Huygens. Huygens theorem. Huygens theory of light. This theorem simply called as a wave theory. This simply called as a wave theory. Simply called as a wave theory. So this wave theory is given by Huygens. Huygens theorem. So this is simply called as a wave theory of light. So so this theory is explained. First postulate given us here. Okay, light is required. Light is required. Light is required in any medium. Okay, propagation in okay, first theorem, first condition they can explain. The first one is the light is required to propagation in any medium. Okay, propagation in any medium. If any medium they can want it, they will propagation of light. So this first condition. Second condition given as here, in case of rarer medium, rarer medium is more than the denser medium. Is more than the denser. The velocity of light in rarer medium is more than the denser medium. So in case of in case of this theorem, the velocity of light is more in rarer medium, less in denser medium. It is a second postulate we give us here. Third postulate we can give us here. Okay, first one is a rarer medium, second one is a denser medium. So we require any medium to propagation. Means here rarer medium is more than the denser medium. Means here the velocity of light in air is more than the water or glass. Means the velocity of light is more in air, less in water or glass also. So this is a second condition given as here. Okay. And third one they will give us here. This theorem is called as a third condition we can give us here, wave nature. Light in pass of the medium by wave nature. Wave nature, because simply called as a wave theorem. Simply called as a wave theory. So light is the pass of the in this pattern, like as waves. This pattern also. Light can be passed on a medium in this pattern as a wave theorem also. So this is a three conditions given as here by Huygens theorem. So this theorem is called as a Huygens theory. First one is a light is required to propagation in any medium. It may be rarer or denser medium also. Second one is in the velocity of light is more in rarer medium and less in denser medium. The second condition. Third condition, light they can require any medium. They will pass off medium in by wave nature. So this type of nature is given as by here Huygens theorem. So this is a second theorem. They can explain the property of light. This is second theorem. Okay. Now, we discuss in third theorem. Third theorem is explained with the light by one of scientists. He is a Max Planck. You see, other scientist is a Max Planck. Max Planck. Okay. Okay. Max Planck. Max Planck. This is called as a Max Planck theorem of light. Okay, according to Max Planck, so Max Planck is a father of modern physics. Is one of simple bit, important bit. We can remember them. So Max Planck is a father of the modern physics. Max Planck is a father of modern physics. Father of modern physics. Max Planck is a father of modern physics. So he gave the one of theorem is simply called as a theory of Max Planck, simply called as a Planck quantum theorem. This is simply called as a Planck quantum theorem. So Max Planck quantum theorem is given as here. Max Planck quantum theorem. This is called as a modern physics. They can be modern physics. They can be based upon the Max Planck theorem. This is simply called as a Max Planck. Okay. They based upon the Planck quantum theorem. Planck quantum theorem is one of modern technique we can use. The modern physics they can be based upon by Max Planck quantum theorem. So this Planck quantum theorem they can explain one of formula we can give us here E equal to h into V. Here E is called as a energy, H is called as E is here energy, H is here Planck constant. H is a Planck constant. The value of H will be here 6.625 into 10 power minus 34 joules. 34 joules. Here V is a frequency. Frequency defined as already we known in previous class. Frequency is defined as the number of waves released on unit time or number of oscillation per unit time is called frequency. Now in this chapter we are discussing so the light is they can pass in this theorem they can pass off the like a theorem is quantum. Quantum is some of energy packets. So the frequency means the number of waves released on unit time. It's called frequency. So frequency is measured in a hertz. So this theorem is called as a Max Planck quantum theorem. E equal to h into V. And also now they confirm E equal to h into V, h into C by lambda. Since here frequency equal to C by lambda. So this is a second relation, you can understand them. Here h into V, V means here frequency equal to C by lambda. C is a now here C is called as a velocity of light in vacuum. The value will be 3 into 10 power 8 meter per second. So this is a C value. So this is a velocity of light in vacuum. 3 into 10 power 8 meter per second. So this is a lambda is called as a wavelength. So lambda is called as a wavelength. C is called as a velocity of light in vacuum. So here this formula they can rewrite as a E equal to h into C by lambda. So this theorem is simply called as a Max Planck theorem of light. Is simply called as a Planck quantum theorem. Formula is given as here E equal to h into V. Okay, here we can discuss the light is can pass off the medium by here quantum. This is a quantum is here energy packets. This is called energy packets. They can pass out the form of the energy packets. This is packet 1, 2, 3, 4, and so on. So this type of packets they can pass off light in a given medium. It may be a rarer medium or it may be a denser medium. So they can pass off the quantum theorem. This is called as a quantumized. This is simply called as a quantum theorem. So formula will be E equal to H into V. E is here energy, H is called as a Planck constant, V is called as a frequency. So in this in this theorem, the light will be passed in any medium by quantum. Quantum is here one of packet of energy packets. So this type of pattern they can pass off if any medium. So this is concept this. Now here according to Max Planck theorem, but he will give the information about the light is passed on a medium. If any medium, he required any medium. He required any medium, maybe or denser medium or rarer medium. Now here the velocity of light is rarer medium is more than the denser medium. So this type of relation is given as here Max Planck also. So he will give the information about the in this regard to this theorem, the light is passed on if any medium, we require any medium to propagation it. So in rarer medium the velocity is more than the denser medium. So this type of configuration given as here Max Planck. So this theorem is called as a Planck quantum theorem. So Max Planck is called as a father of the modern physics. Father of the modern physics also. So this is a third theorem, they can be explained by the Max Planck also. This theorem is called as a Planck quantum theorem. Okay, now discussing fourth theorem. Fourth theorem will be here Maxwell theorem. Maxwell theorem. Maxwell theorem. This is a fourth scientist, they can give the information about the Maxwell theory of light. This is a fourth theorem, they can explain by the Maxwell. This is a first scientist, they can explain the Maxwell theorem. Fourth scientist. So here in this theorem they can explain they can explain according to this theorem. So light is contain electromagnetic waves. Light is contain electromagnetic waves. So light is electromagnetic wave. So it is not required. So is not required. Is not required to propagation. Propagation is not required to any medium. Is not required to any medium to propagation. Okay. So according to Maxwell theorem, so Maxwell is give information about so the light waves is called as a electromagnetic wave. So this electromagnetic wave is not required to any medium to propagation. So in the this is the first statement. Second statement given us here, the velocity of light is maximum in rarer medium. Okay, rarer medium. So this is statement given as here Maxwell theorem. So he will give the one more example based upon this electromagnetic waves. They can depend upon intermediate. These waves can be released in intermediate between the electricity and magnetism. So they will give one information about. So this is called as this is a electricity I. This is a magnetism B. So the waves can be released this type of pattern also. So they are called, both are here, okay, both are here, okay, perpendicular each other. So both are contained, okay, perpendicular each other, this pattern also. So this is I means here, okay, electricity, this is B means here magnetism. So these waves can be released in is the intermediate between the electricity and magnetism. So these electricity and magnetism both are, okay, perpendicular each other. So they can pattern this type of pattern. This is magnetism, this is electricity. If they will turn, this is magnetism, this is electricity. So this type of magnetism they can form, this is called as a electromagnetism. So this wave is called as a this light wave is called as a electromagnetic waves. So it is not required to any medium to propagation. So this is called as a electromagnetic waves. So finally the light wave is called as a electromagnetic waves. So these electromagnetic waves, they cannot require to any medium to propagation. So this type of matter also. So the velocity of light is maximum in rarer medium or minimum in denser medium also. Minimum in denser medium also. So this is a statement is given as here in your scientist by Maxwell. So this is Maxwell is a final theorem. They can explain the property of light also. So it is a the velocity of light in vacuum C will be here. The value will be 3 into 10 power 8 meter per second. So this is a maximum velocity. It is a maximum velocity of light in vacuum. If medium will be changed, the velocity also change. They can depend upon the nature of medium also, nature of material also. Okay, now so they are the some type of theorems. They can explain the light of simply called as light theorems. Once again, the first theorem will be here. First theorem will be Newton's theorem. This simply called as a particle nature of the light. They can explain the theorem will be here Newton particle theorem based upon the light. Second theorem will be second theorem will be here second theorem will be here Huygens theorem. They can explain the based upon the Huygens theorem. They can the light, the waves contain the wave nature. The wave nature of light is called as expressed from the Huygens. Third scientist explain the Max Planck. Max Planck is explain the one of theorem will be Max Planck quantum theorem. So this Planck quantum theorem is give the information about the quantum theorem of light. Means the light can pass in the medium by quantum, because a quantum means energy packet. A small packets, they can migration of the light can be medium in be here energy packets. They can be 1, 2, 3 and so on. They will pattern, they could follow. The same way here, final theorem will be here Maxwell theorem. So this Maxwell theorem is this Maxwell theorem is given. He gives the information about the light waves contain electromagnetic waves. So they can be released in between the electricity and magnetism also. So this is these two pattern are both are perpendicular to each other, electricity and magnetism. So these waves called as a electromagnetic waves. So these electromagnetic waves is not required to any medium to propagation also. So light electromagnetic waves, you can explain the give information about the Maxwell theorem also. So these electromagnetic waves is waves, they can be released in between the electricity and magnetism. So they can be give information about the Maxwell theorem. So these electromagnetic waves contain some properties. What are the properties we can discuss now? So these electromagnetic waves are produced by accelerated charge. These electromagnetic waves can be produced by accelerated charge. So the waves travel in the free space in the speed of light will be the velocity will be here the same. This is the value of this 3 into 10 power 8 meter per second also. Now here these electromagnetic waves are the waves of carry energy to and momentum. Since they carry momentum for electromagnetic waves is expressed in passes called radius pressure. So here these electromagnetic waves, they can be right in one of order, like as a decreasing order of the frequency is this called as a electromagnetic spectrum. Simple, we can understand spectrum is one of the diagram. We can indicate the frequency of light from increase to decrease also. This called decreasing order of frequency. They can explain one of picture. So this picture is called as a electromagnetic spectrum. Now we can discuss the electromagnetic waves. We can discuss one by one also. So this is a very important concept. We remember them. Now we're discussing electromagnetic waves. This is called as light. Light contains electromagnetic waves. Now we're discussing some type of waves we contain the electromagnetic waves. Now we're discussing one by one. First one is first rays is called as a gamma rays. A simple we're discussing cosmic rays are available. Cosmic rays are high energy, but we can discuss from gamma rays. First we're discussing gamma rays. Next beta. Next alpha. This pattern we can discuss one by one. Next X-rays. Okay. Next we're discussing ultraviolet UV. Next IR. IR means infrared radiation. Infrared IR radiations. IR rays. IR rays. Next we discuss microwaves. Next radio waves. So they are the different type of rays we can be discuss one by one. Now first gamma rays they can be discovered by Becquerel, Henry Becquerel and Curie. Gamma rays. So this gamma rays can be discovered by Becquerel, Henry Becquerel. Becquerel and Curie. Gamma rays. Now X-rays they can be discovered by Roentgen. X-rays can be discovered by Roentgen. X-rays can be discovered by Roentgen. UV rays they can be discovered by Ritter. UV rays they can be discovered by Ritter. Now also UV rays UV visible also. UV visible. EV visible, like as a IR rays and microwaves and radio waves. UV visible is discovered by Newton. UV rays can be discovered by Newton. IR rays is discovered by the Herschel. Microwaves is discovered by Hertz. And radio waves is discovered by Marconi. So they are the waves. So these electromagnetic waves contain so many rays. They are called as here gamma rays, X-rays, UV rays, UV visible rays, IR rays, microwaves and radio waves. So this is a radio waves. So this all waves is called as a electromagnetic waves. So the light contain electromagnetic waves. Scientists based upon this once again gamma rays they can be discovered by Becquerel and Curie. Second, X-rays were discovered by Roentgen. And also radio waves is discovered by Marconi. So they are the different scientists, they can discover in different waves. But all different waves is not contain same frequency, they contain different pattern also. They will be now discussing the frequency of the gamma rays will be 10 power 19 to 10 power 19 to 10 power 21. So this is a frequency value. They contain H. And X-rays contain 10 power 16 to 10 power 19 H. Okay, UV rays contain, okay, 10 power 14 to 10 power 16. 10 power 14 to 10 power 16. Okay, now visible rays, UV visible rays, they contain, okay, 3.7 to 10 power 14 to, okay, 7.5 into 10 power 14 H. This is called as a visible range. Okay, so this is the frequency. Then wavelength will be here. Lambda will be 400 nanometers to 750 nanometers. So this is a lambda value of, lambda means here wavelength. So the wavelength of the visible range is 4.75 400 nanometers to 750 nanometers is rough value. Like as here, microwaves contain 10 power 7 to, sorry, IRS. Okay, IRS. Okay, IRS contain 3 points, okay, 10 power 11 to 10 power 14. Okay, now microwaves contain 10 power 7 to 10 power 11. Okay, next radio waves contain, okay, below 10 power 7. Below 10 power 7 hertz. So this is a frequency. So this is a frequency based upon. Now if you wanted to wavelength, they will convert in different. UV visible they contain different pattern. We see in different colors in UV visible. This is called a visible radiation. They contain they contain different pattern. They will form as a this type of pattern also. Because a VIBGR, VIBGYOR, they contain different colors we observe. They contain, the violet contain 400 nanometers, red contain 750 nanometers. So this is a wavelength value. VIBGR, violet, indigo, blue, green, yellow, orange, red. It's called VIBGR colors. They contain the wavelength will be in between 400 nanometers to 750 nanometers. So this is a wavelength. The frequency they contain 3.7 10 power 14 to 7.5 10 power. So this contains 7.5 maximum to 7.5 into 10 power 14 to, this is a 3.7 into 10 power 14 H. So this is a frequency of visible radiation. So the visible radiation, the frequency will be, okay, 7.5 into 10 power 14 to 3.7 into 10 power 14. So this is a radiation of visible radiation. So okay, they can be used. The source of the light will be different pattern also. Now it will be different pattern also. So the gamma rays, they are coming from nuclear charge. Nuclear changes in the radioactive nuclei such as uranium, simply called as a nuclear reaction. Means here radioactive elements. Like the uranium, thorium, okay, plutonium, they are the some type of elements. They will produce a nuclear, okay, some release these waves called as a gamma rays. They will coming from radioactive elements, okay, such as a uranium. Gamma rays, they can prepare, the source of light will be here. So this will be radioactive elements. They will produce the gamma rays also. In case of X-rays, they coming from high energy electron shifting of heavy metals. Okay. So here, like as a X-rays, these X-rays is coming from, okay, high energy transformation of heavy metals. Heavy metals, they can produce the X-rays. They will contain the high energy transformation from high energy to low energy. Heavy metals, the metal target of high melting point, the highly electromagnetic waves stopped in heavy metals target. They will be coming from heavy metals. Okay. Now anyhow, the ultra rays, UV rays, they coming from sunlight in arc lamp or okay spark. This UV rays are coming from sunlight. This UV ray is coming from sunlight or arc lamp. This is coming from sunlight or arc lamp. Now UV visible is coming from also sunlight, white and hard bodies. UV visible. Sunlight. The same way here, the IR rays is coming from lamp with theoretical filament. Lamp, because the lamps they coming. This IR rays coming from lamp. Okay, microwaves they coming from electric circuit. Because the microwaves we can use in oven. And also same radio waves they can produce the electrical circuits. So they are the different type of sources we can use in coming from. We can use in different arrays. We can use different patterns also. Once again, the X-rays, the main source will be here radioactive elements. Sorry, gamma rays. Gamma rays, the main source of coming from gamma rays will be heavy radioactive metals. X-rays is coming from heavy metals. They will be treatment of highly, the energy will be transferred from the heavy rays, heavy metals. UV rays is coming from sunlight or arc lamp. Visible is coming from sunlight, and IR rays is coming from lamp with theoretical filament, lamp. Microwaves and radio waves are coming from electrical circuits. So they are the different type of sources we use in daily life also. Now in this chapter we discuss in different type of properties of light also. So this is a second topic. So this is called as a electromagnetic spectrum. In case of electromagnetic spectrum, they contain the high frequency will be here gamma rays. The low frequency will be here radio waves. Radio waves contain very low frequency. They contain below 10 power 7 hertz here, but gamma rays they contain 10 power 21, maximum 21. Okay, the frequency of gamma rays will be, once again we discuss the 10 power 19 to 10 power 21 hertz. The frequency of X-rays will be 10 power 16 to 10 power 19. The frequency of UV rays will be 10 power 14 to 10 power 16. Okay, now the UV visible, the frequency will be 3.7 into 10 power 14 to 7.5 into 10 power 14. IR rays, the frequency will be 10 power 11 to 10 power 14. Okay, microwaves, the frequency range will be 10 power 7 to 10 power 11. Radio waves, the frequency in between below 10 power 7 hertz. So they are the frequency of some type of waves we can discuss. So this is very easy and very interesting and very important. Ask us in your examination also. In the examination they ask us which of the following ray contain high frequency or which of the following contain low frequency. Some type of bits regard as this concept also. This type of pattern we can discuss now also. Now we are discussing the properties of light. Now discussing and ask us the main properties will be approximately 5 to 6 property we can discuss very frequently we can discuss now. This type of questions ask as the property of light is so many type of properties we can discuss, but in our examination they ask us 4 to 5 type of properties of light. Properties of light. First property will be light pass on a straight line. On a straight line. Second will be dispersion of light. Dispersion of light. dispersion of light. This is second property of light, dispersion. Third one be scattering. Scattering of light. Fourth one is the reflection of light. Fifth one is a refraction. Refraction of light. Sixth one is a total internal reflection. This is very important. Seventh one is a diffraction. Diffraction of light. Eighth one is a interference. Ninth one is a polarization. Polarization. So they are the different type of properties of light. We can discuss one by one. So in our examination point of view, so they are the some type of properties asked as a very frequently will be here. Dispersion of light, scattering of light, reflection, refraction, and total internal reflection. So these are the very important topic we can ask as a in our examination also. So very frequently they ask us this type of property of light we can ask as your examination also. First one is the properties of lights are totally 9 models, 9 properties. These out of 9 properties, we will very important properties will be 5. They will be dispersion of light, scattering of light, reflection of light, refraction of light, and total internal reflection. So these are the very important properties we can now discuss one by one also. So light contains so many properties. So these are the some properties of light. Once again, the first property will be light pass on a straight line. Second property will be here dispersion of light. Third property will be here scattering of light. Fourth one reflection of light. Fifth one refraction of light. Sixth one is a total internal reflection of light. Seventh one is a diffraction of light. Eighth one is a interference of light. And ninth one is a totally polarization. So they are the different type of properties of light now discussed in one by one. So this is a very important topic. So these 5 properties is very important. Once again, dispersion of light, scattering of light, reflection, refraction, and total internal reflection. So these are the 5 properties is very important asked in our examination also. So in this chapter we are discussing some type of numericals based upon asking this chapter based upon reflection and refraction also. These 2 are very important. Reflection and refraction, these 2 are very very important is asked in our examination also. Now discussing one by one. First property will be light pass on a straight line. So, according to some scientists, they can give you some information about this topic. And the light is passed on a straight line. They can explain so many scientists give the different type of pattern also. Now here, light they can always pass on a straight line. We can observe different situation. Situation in daily life also. For example, light they can be always follow the straight line but not curve rays. So generally they will pass us, this trend will be follow. So how they can be follow, how they can be concluded. So we can see they get formation of, for example, so this is a light, they could produce a light. Light, you will see if they will be touched in any opaque object. So this is an opaque object, like as a stone. This is a stone. This is an opaque object. Means light cannot be passed them. Now on this stone, the shadow will be formed. This screen also. This is a shadow. This is a shadow. They will form on screen also. So this light is pass on any opaque object. It will formation of shadow. Means if light is, they will go in some curved direction, so this shadow is not formed. Shadow is not formed. So in the same way, we can observe the formation of solar and lunar eclipse also. Now here we can observe, so this is the sun. So this is a sun. So this is a earth. So this is a moon. Now in case of the sun is a luminous, but earth and moon is a non-luminous. So the rays coming from sun, so this sun coming from sun to reach the earth. Okay, now we cannot observe the moon. In this case, we cannot observe the moon, but because the light is only pass on earth, but not moon also. So okay, in this case, they form as a lunar eclipse. Lunar eclipse. This case the formation of lunar eclipse. If in this case we observe this is the sun, so this is the moon, so this is the earth. Okay, in this case the sun rays will be passed on only for moon, but not we cannot reach the earth. We cannot reach the earth. So in this case, we cannot observe. We cannot observe in the sun. So this is called as a solar eclipse. So this is a solar eclipse. So this is a lunar eclipse. So now here, if the light is passed on curved rays, they cannot form the solar eclipse or lunar eclipse. So in this activity we can be conclude that the light is passed on a straight line, but not curved direction, but not curve. They only pass on a straight line. So this is the examples. Simple we can understand. If any opaque object, the light is if the light is passed on if any opaque object, they form as a shadow. This shadow contains sometimes two types, like as a umbrella, penumbrella, or umbra, or simply called as a penumbra. They form as a different. So this is the activity. They will be prove that so light is passed on only for straight line, not a curved direction. So this is a first property of light. So light is passed on a always for straight line. So this is a first property of the light. So the formation of shadow, first example, the formation of shadow. Second example, formation of solar and lunar eclipse also. So this is the activity they will done. So they will prove that light is passed on a straight line. So this is a straight line. This is a first property. Simple. In your examination, light is a pass on a straight line is an example of formation of solar eclipse and lunar eclipse, and also formation of shadow. So these shadow are two types. There will be umbra and penumbra also. So this is the first property of light. So this property is asked as a very rarely. Okay. So this is the first property of light we can discuss in the chapter also. So once again, light is passed always from straight line. These examples are formation of shadow. Second one is a formation of solar and lunar eclipse also. They are the different examples. They can be conclude that the light is passed on a only for straight line. So this is a first property of light. So this is very easy. Now second property of light will be here. Now discussing dispersion of light.
వెల్కమ్ టు హర్షిత్ ఇన్స్టిట్యూట్. విజయవాడ మహానగరంలో 2009 సంవత్సరంలో ప్రారంభించబడి అనేక వేల మంది అభ్యర్థులను ప్రభుత్వ ఉద్యోగులుగా తీర్చిదిద్దిన మన హర్షిత్ ఇన్స్టిట్యూట్ గత 12 సంవత్సరాల్లో సుమారు 18,000 మందిని ప్రభుత్వ ఉద్యోగులుగా తీర్చిదిద్దింది. ఇప్పటి వరకు 5 సార్లు నిర్వహించినటువంటి ఈ యొక్క నోటిఫికేషన్స్లో అనేక సార్లు స్టేట్ ఫస్ట్ సాధించినటువంటి ఘనత మన హర్షిత్ ఇన్స్టిట్యూట్ది. ప్రస్తుతం మన హర్షిత్ ఇన్స్టిట్యూట్ యొక్క ప్రత్యేకతలు 24/7 24 గంటలతో కూడినటువంటి లైబ్రరీ సదుపాయం. అంతేకాకుండా ఇదే లైబ్రరీలో మనకు అత్యున్నత ప్రామాణిక గ్రంథాలు అందించడం అనేది జరుగుతుంది. నెక్స్ట్ ఈ లైబ్రరీతో కూడినటువంటి ఈ లైబ్రరీలో మనకు వివిధ సబ్జెక్టులకు సంబంధించినటువంటి ఎకానమీ, పాలిటీ, హిస్టరీ, జోగ్రఫీ మరియు అన్ని సబ్జెక్టులకు సంబంధించినటువంటి పూర్తి స్థాయి స్టడీ మెటీరియల్ మీకు అందించడం అనేది జరుగుతుంది. అంతేకాకుండా జాయిన్ అయిన ప్రతి అభ్యర్థికి పూర్తి స్టడీ మెటీరియల్ మరియు అభ్యర్థి ఏ ఎగ్జామ్ అయితే రాయకపోతున్నాడో ఆ ఎగ్జామ్కు సంబంధించినటువంటి సిలబస్ ప్రతి ఒక్కరికి అందించడం అనేది జరుగుతుంది. అంతేకాకుండా స్టేట్ ఫ్యాకల్టీ మన ఇన్స్టిట్యూట్లో బోధించేటటువంటి ప్రతి ఫ్యాకల్టీ కూడా ఎకానమీ, పాలిటీ, అర్థమెటిక్ అండ్ రీజనింగ్ తదితర సబ్జెక్టులకు సంబంధించినటువంటి ప్రతి ఫ్యాకల్టీ కూడా ఎంతో అనుభవము, అంకితభావము కలిగినటువంటి ఫ్యాకల్టీ మన యొక్క ఇన్స్టిట్యూట్లో ఉండడం అనేది జరుగుతుంది. అంతేకాకుండా మన ఇన్స్టిట్యూట్ యొక్క మరొక ప్రత్యేకత డైలీ టెస్టులు నిర్వహించడం మరియు వీక్లీ, మంత్లీ ఎగ్జామ్స్ నిర్వహించి ఆయా ఎగ్జామ్స్ నందు బహుమతి ప్రదానం చేయడం అనేది మన ఇన్స్టిట్యూట్ యొక్క ప్రత్యేకత. అంతేకాకుండా నాన్ మ్యాథ్స్ స్టూడెంట్స్ ఎవరైతే ఉన్నారో వాళ్ళపై ప్రత్యేక శ్రద్ధ చూపించడం, నెక్స్ట్ వాళ్ళకి ప్రత్యేక తరగతులు నిర్వహించడం అనేది జరుగుతుంది. తప్పనిసరిగా మీరు ఒక్కసారి మన హర్షిత్ ఇన్స్టిట్యూట్ని ఒకసారి సందర్శించండి. హర్షిత్ ఇన్స్టిట్యూట్లో ఉన్నటువంటి ప్రతి అంశాన్ని క్షుణ్ణంగా అవగాహన చేసుకోండి మరియు ప్రస్తుతం ఎవరైతే హర్షిత్ ఇన్స్టిట్యూట్లో ఉన్నారో ఆ యొక్క విద్యార్థుల్ని వాకప్ చేయండి. మన యొక్క పరిస్థితుల గురించి అవగాహన చేసుకున్న తర్వాతే మన యొక్క హర్షిత్ ఇన్స్టిట్యూట్లో జాయిన్ అవ్వమని కోరడం జరుగుతుంది.
Dispersion of light. Okay, dispersion of light is one of property. Okay, now the light is passed on a prism. We can observe simple we can observe there as a so this is a one of prism. Okay, and this prism is made by glass. This is flint glass. They can use a making of prism. This is a glass. This is a flint glass. This is simply called as a prism. This contains triangle nature. Okay, now the light is passed on a prism. This is source of light. The light is coming from this. It will split into 7 colors. 7 colors. It will split into 7 colors also. Okay, these colors are, the order will be here, this order, VIBGR, V, I, B, G, Y, O, R. So this order they can follow. So this is a violet to red color. So violet to red color. So this is the VIBGR colors. So here, okay, violet contain maximum frequency and minimum wavelength. Here, okay, red contain maximum wavelength and minimum frequency. So this is a reverse pattern also. So here, okay, now once again, dispersion of light is a property, so they can explain the response. When a beam of light is passed on a prism, it will split into 7 colors. So these colors called as a VIBGR. So this phenomenon is known as a dispersion of light. Once again, dispersion of light is defined as when a beam of light is passed on a prism, it will split into 7 colors. It will be split into 7 colors. So these colors are VIBGR: violet, indigo, blue, green, yellow, orange, red. So these colors they will produce. So this phenomenon is known as a dispersion of light. Okay, in these 7 colors, the maximum frequency will be here violet color. The minimum frequency will be here red color. So minimum, okay, sorry, red color is minimum frequency. So the minimum wavelength is a violet color. So the wavelength value will be here 400 nanometers. This is a minimum wavelength. And the maximum wavelength will be here 750 nanometers. 7 nanometers. So here violet contain maximum frequency, minimum wavelength. So here red contain maximum wavelength and minimum frequency. So these are the reverse property. Both are violet and red also. So here the maximum deviation of light is the color will be here, maximum deviation will be here violet color. So violet contains maximum deviate towards the normal, maximum deviate. So violet is maximum deviate, red is a minimum deviate. So the minimum deviating color is a red color. So the red color will be, we can appear a long distance. So we can use as a traffic signal for only for red color, but not violet color. Because the violet color is a maximum deviate, but red color is a minimum deviate. So the minimum deviate color will be here red color. We can be observe the long distance also. Second parameter we can discuss them. The red contains the maximum wavelength and minimum frequency. It contains minimum energy and maximum wavelength. So we will be observe a long distance. So the red color will be used as a traffic signal or danger light. We can be simply called as a indication of dangers, because we can observe at a long distance also. So violet contains minimum frequency. Violet contains the maximum frequency and minimum wavelength, and red contains maximum wavelength and minimum frequency. So this is order. So this phenomenon is known as a dispersion of light. So this contains dispersion of light. So this prism is called as a angle of D. This angle called as a angle of A. Means here there is a one of formula they were given in this chapter, in this basic upon. So n equal to sine A plus D by 2 by sine A by 2. Now here n is called as a refractive index. Refractive index. N is one of constant. This can be called as a refractive index. Second here, A is called as a angle of prism. A is a angle of prism. Now here D is called as a angle of deviation. So angle of deviation is maximum in violet color, minimum in a red color. So n equal to sine A plus D by 2 by sine A by 2. Now here n is called as a refractive index, which is one of constant of the prism. Refractive index. Here A plus D by 2 by sine A by 2. So this is the formula we can use to easily find the refractive index of any unknown material. A is a angle of prism, D is a angle of deviation. So here the formula will be n equal to sine A plus D by 2 by sine A by 2. So n is a refractive index, this simply called as a constant. So this refractive index is depending upon nature of the material also. So this refractive index is more in denser medium, less in rarer medium also. So this is one of formula n equal to refractive index. So this is one of constant. So this refractive index is depending upon nature of the material. For denser medium, n value is more. For rarer medium, n value is less also. Now formula n equal to sine A plus D by 2 by sine A by 2. Once again here A is a angle of prism, D is a angle of deviation. So in these 7 colors of WIPGR, the maximum deviation color will be violet, the minimum deviation color will be here red also. So the formula n equal to sine A plus D by 2 by sine A by 2, they can easily understand. In your examination, ask as based upon the numericals based upon this. Now here n equal to sine A plus D by 2 by sine A by 2. So in your examination, they can give the sine A and D values. Angle of prism and angle of deviation is both are given. Ask as a angle of refractive index. Simple pattern also. So this is the second property of light. This is known as a dispersion of light. Once again, dispersion of light is defined as when a beam of light is passed on a prism, it will split into 7 colors. So this phenomenon is known as a dispersion of light. So these 7 colors are WIPGR: violet, indigo, blue, green, yellow, orange, red. Now here in these 7 colors, the violet contain maximum frequency, red contain minimum frequency. Okay, now in the violet contain the minimum wavelength, red contain the maximum wavelength. So if the maximum deviate color will be violet, the minimum deviation color will be here red also. So in minimum deviating color will be red, so it is used as a traffic signal, because which can appear as a long distance also. But violet color is not appear as a long distance, because this is a maximum deviate color. It contains maximum frequency and minimum wavelength also. So this is a concept regarded as a dispersion of light. So here one more formula they can be given in this chapter also. Dispersion of light will be one of formula, n equal to sin a plus d by 2 by sin a by 2. Here a is called as a angle of prism, d is a angle of deviation. N is called as a refractive index. This refractive index they can depend upon nature of material also. So this refractive index is depending upon the density. N is direct proportional to the density. Here N is a directly proportional to the density. Here if rarer medium they contain minimum refractive index, the denser medium they contain maximum refractive index. So this is a one of relation. This is a second property of dispersion of light. Okay, now a third property of light will be here scattering of light. So this is a third property of light, scattering of light. Scattering of light. So scattering of light. So this is a one of concept, one of property of light. Now scattering of light. Now this scattering of light defined as when a beam of light, this is a beam lights, it will be touching any colloidal solution. This will be called as a colloidal solution. This will be called as a Sol is called as a colloidal solution. When the beam of light is passed on a colloidal solution, it will be split in all direction. The particle of light is touch on a colloid solution. The colloid particle, the beam of light is passed on a colloid solution. The light is passed on a colloid particle. It will split in all directions. Because scattering. Scatter means it will split in all directions. So this is pattern. This is pattern they can observe. So this concept is called as a scattering of light. Scattering of light. Scattering of light is a one of property. So here when the beam of light is passed on a colloid solution, they will touch in colloid particles, so it will split in all direction. It will split in all direction. So this pattern is called as a scattering of light. So here we can be what they will observe in daily life in different applications. First application will be here, skies appears as a blue color. Second one is a star. Second a sun. Sun is appear. Sun is appear morning and evening. Evening red color. So these are the main applications we use in daily life. When the sky is appear as a blue color and sun is appear as a morning and evening, we appear as a red color. Because we can observe. Because what is the reason? Because now what is the scattering of light? Scattering of light is phenomena when the beam of light is passed on a colloid solution, it will split into all direction. They will be simply called as a the beam of light is passed on a colloid solution. We can touch in colloid particles. It will split in all directions. So this phenomena is known as a scattering of light. Now we can see, observe. So this is the earth. This is a person, we can observe. So morning the sun is appear as here. In afternoon they will reach this pattern also. In evening here. This is a morning time. This is a evening time. This is a afternoon time. Now here we can observe him. If observe the early morning, if you can observe the early morning, so we can observe the sun is a long distance. In our colors will be here VIBGY colors, V I B G Y O R. These colors, the maximum wavelength color will be here. Red contains maximum wavelength, and minimum deviate. So red content maximum wavelength and minimum deviate. So we can observe as a this color will be observed and long distance also. Yet in case of morning and evening, the sun will appear as a long distance. We can the distance of sun and earth is a very long distance. So we can in these 7 colors we can observe only for red color, because we can contain maximum wavelength and minimum deviation. So we can observe in case of morning we appear as only for red color. In the evening we observe only for red color, because this color will appear as a long distance, but not this color also. So morning and evening we appear as a from the sun we contain sun earth distance will be here long distance. We appear as a long distance color will be here only for this red color. So in case of morning and evening we observe only for a red color will be observed. In case of afternoon, this is a very short distance we can observe compared to the evening and morning also. So in this color, in this situation we observe that all colors will be mixed. The simple color as a white color. So all colors will be mixed. They will combine as a appear as a for only for white color. In the afternoon we appear as a white color. In the evening and morning we observe only for red color. So this is one application, applications of scattering of light. Once again, the scattering of light means the beam of light is passed on any colloid solution, simply called colloid solution. The ray is touched on a colloid solution, a particle of colloids, it will split in all directions. So this called as a scattering of light. So what is the applications we use in daily life will be, the first application will be here, sky is appear as a blue color, and as a morning and evening sun is appear as a red color. In afternoon we can appear as a white color, because in the afternoon we observe is a very short distance. We can observe the all color will be mixed. We can appear as a only for white color. And morning and evening they appear as a red color also. So this is a daily applications we can use. Now first application we use sky appear as blue color, because the particles of water droplets, like moisture, humidity which are present in atmosphere, the beam of light is passed on these water droplets. We can observe, we can scatter off the blue color, this blue color. So the sky appear as a blue color also. So this is one of application we use in daily life also.
వెల్కమ్ టు హర్షిత్ ఇన్స్టిట్యూట్. ఇక్కడ మనకి ఏపీ సచివాలయం ఆల్రెడీ మనకి ఒక వీడియో చేయడం అనేది జరిగిందండి ఏపీ సచివాలయం గురించి. త్వరలో సచివాలయం పోస్టులు ప్రకటిస్తున్నామని చెప్పేసి మనకి అన్ని పేపర్లో కూడా అన్ని మెయిన్ న్యూస్ పేపర్స్ అన్నింటిలో కూడా రావడం జరిగింది. మోర్ దెన్ 14,000 14,000 పోస్టులు, అరౌండ్ 15,000 ఇంకా పెరగొచ్చు కూడా అన్ని పోస్టులు. కాబట్టి ఈ పోస్టులు అంటే కూడా అతి త్వరలో వాళ్ళు ఏమన్నా ఫిబ్రవరి నెలలో అని చెప్పేసి అన్నారు. ఖచ్చితంగా ఫస్ట్ వీకా సెకండ్ వీకా ఈ నెలలో తప్పనిసరిగా నోటిఫికేషన్ అనేది వస్తుంది, 100% వస్తుంది నోటిఫికేషన్. కాబట్టి దానిలో పెట్టుకుని ఎవరైతే సీరియస్ ఆస్పిరెంట్స్ ఉంటారో, ఎవరైతే సచివాలయం పోస్టులు, ఆ పోస్టుల్లో కూడానండి కొన్ని రకాల పోస్టులకి ఫస్ట్ దానికి నెక్స్ట్ ఫస్ట్ ఒక నోటిఫికేషన్ కొన్ని పోస్టులకైతే రకమైనటువంటి ఎగ్జామ్స్ ఉంటాయి. 2-3 కేటగిరీస్కి ఏమో సపరేట్ ఉంటుంది. ఎలా చదవాలి, ఏం చదవాలి, ఎలా చదివితే మనం ఫస్ట్ అటెంప్ట్లో జాబ్ సంపాదించుకుంటామనే విషయాలన్నీ కూడా క్లియర్ కట్గా మీకు ఎక్స్ప్లెయిన్ చేయడం జరుగుతుంది. దానికి సంబంధించినటువంటి ఏపీ సచివాలయం నూతన బ్యాచ్లు అనేవి 8th ఫిబ్రవరి నుంచి స్టార్ట్ అవుతున్నాయండి. ఇక్కడ మన హర్షిత్ ఇన్స్టిట్యూట్లో 8th ఫిబ్రవరి నుంచి స్టార్ట్ అవుతున్నాయి. ఆల్రెడీ చాలామంది స్టూడెంట్స్ ఎన్రోల్ అయ్యారు. వాళ్ళకి స్పెషల్ బ్యాచ్ మార్నింగ్ 9 కల్లా స్పెషల్ బ్యాచ్ అనేది స్టార్ట్ అవుతుంది. తర్వాత ఫస్ట్ నుంచి కూడా ఎవరైతే ఈ యొక్క క్లాసులకి వస్తూ అటెండ్ అవుతూ ఉంటారో వాళ్ళకి సిలబస్ మీద పూర్తిగా అవగాహన అనేది రావడం జరుగుతుంది. ప్లస్ ఇంకా ఒకటండి, మరలా చాలాసార్లు చెప్పాను, మరలా ఇంకొకసారి మీకు రిమైండ్ చేస్తున్నాను. 2023 అనేది గోల్డెన్ పీరియడ్. ఇది ఒక గోల్డెన్ ఇయర్. ఎందుకంటే 2024లో మనం చేసేది ఉండదు. ఇక్కడ మనకి 2024 ఎలక్షన్ ఉంది. ఎలక్షన్లో మనకి ఎలక్షన్ కూడా అనేది ఇంప్లిమెంటేషన్ వచ్చేస్తుంది. తర్వాత మనం చేసేదే ఉండదు. కాబట్టి 20 అయిపోయిన తర్వాత, ఎలక్షన్ అయిపోయిన తర్వాత కూడా ఆ తర్వాత 25, 26 ఒక 2-3 ఇయర్స్ వరకు మనం అట్లీస్ట్ 2 ఇయర్స్ వరకు మనం ఏమి ఎక్స్పెక్ట్ చేయాల్సి పని ఏమీ ఉండదు. కాబట్టి 2023 ఎందుకంటే ఏ సీఎం అయినప్పటికీ కూడా ఆ ముందు సంవత్సరాన్ని అందరినీ కూడా సాటిస్ఫై చేయాలి, అన్ని వర్గాల వారిని. అది నిరుద్యోగులను కావచ్చు, లేకపోతే మహిళలు కావచ్చు, లేకపోతే రైతులను కావచ్చు, ఎవరైనా కావచ్చు, వాళ్ళందరినీ సాటిస్ఫై చేయాలనేటువంటి దృఢ నిశ్చయంతో ఉంటారు ఏ సీఎం అయినప్పటికీ కూడా. కాబట్టి తప్పనిసరిగా 2023 అనేది మనకి ఎవరైతే నిరుద్యోగులు ఉన్నారో వాళ్ళందరికీ కూడా గోల్డెన్ ఇయర్. కాబట్టి స్పెషల్ రిక్వెస్ట్, మీరు ఎట్టి పరిస్థితుల్లో కూడా 2023ని ఉపయోగించుకోండి. తప్పనిసరిగా ఏదో ఒక జాబ్ ఫస్ట్ మీ కాళ్ళ మీద మీరు నిలబడేట్టుగా ఏదో ఒక జాబ్ని సంపాదించుకున్నట్టుగా ప్రయత్నం చేయండి. ఒక్కసారి మన హర్షిత్ ఇన్స్టిట్యూట్ని విజిట్ చేయండి. మేము ఇక్కడ అందుబాటులో ఉంటాం, మన ఫ్యాకల్టీ ఉంటారు. వీళ్ళందరూ కూడా మీకు కావాల్సినటువంటి గైడెన్స్ అంతా కూడా ఇవ్వడం అనేది జరుగుతూ ఉంటుంది. కాబట్టి ఏపీ సచివాలయం నూతన బ్యాచ్లు ప్రారంభమవుతున్నాయండి 8th ఫిబ్రవరి. ఒకసారి మీరు మన ఇన్స్టిట్యూట్ని విజిట్ చేయండి. థ్యాంక్ యూ వెరీ మచ్.
Sky appears blue color, on the ocean they can also blue color. Because the sun rays they will pass on the water droplets, tiny water droplets. They can act as a colloids, tiny water droplets. Okay, it will split in all direction. The blue color will be scattered maximum, so we appear as a only for blue color of sky. So this is the different applications of scattering of light also. So this is the very two application of scattering of light also. Okay, now discussing third property of light will be reflection of light. This is very important concept. Third property of light is a reflection of light. This is a very important concept. This is very easy and very frequently asked as a different questions regarding as a reflection of light. Property number 3. Okay, now we're discussing next property, reflection of light. Reflection of light. Reflection of light. Okay, this is one of property of light. Same property they can express in sound also. Reflection of sound. Same property, reflection of light also. Now discussion reflection. How they can understand? First we discussing one of activity. Simple example we can explain them. Now this is a one of glass. Okay, this glass is coated with one of silver oxide Ag2O. So this is a glass, it will coated in back side with silver oxide. Now this is a one of okay, imaginary line, this is called as a normal. This is called as a imaginary line, this is called normal. Now the beam of light is coming from source. If any distance, they will touch in one of position of, okay, mirror. It will be same medium back in bounds. So this is called as a I, this is called as a R. I is called as a incident ray, R is called as a reflected ray. And the beam of light is coming from any object, any source. They will be touched in any glass or mirror. They will come in same medium back in bounds. Okay, this angle, this is called as a I, this is called as a R. This is called as a angle of I. This is the angle of I, means the angle in between normal and incident ray. Angle of R means in between, okay, R and N also. Here N is called as a normal, this simple called as a imaginary line. This is only for imaginary. Okay, this is normal. It will be perpendicular into the plane of glass, if any material. Okay, when the beam of light is passed on a mirror or any smooth surface. Once again, when the beam of light is passed on any mirror or smooth surface, it will be coming back in bounds in same medium. This is known as a reflection of light. Once again, when a beam of light is passed on any smooth surface, it will be, okay, back in bounds in same medium. Is known as a, okay, reflection of light. So here the I is called as a angle of I is called as a incident angle. They will be in between with normal and incident ray. Here angle of R is called as a, okay, angle of reflection. They will be in between, okay, in between the R and N also. Here in this case, reflection, they will take place in two conditions. The first condition will be here, angle of incidence is always equal to angle of reflection. Condition number 1. Condition number 2, here I, R, N are lie in same plane. Lie in same plane. This is a condition number 2. Now here, I means here incident ray, R means here reflected ray, N means here normal. These three are lie in same plane. So this is the condition number 2. So this condition will be satisfied. This condition will be satisfied. Now, okay, then it is called as a reflection. Okay, now here, okay, and now here in this topic we discuss in, this is called as a reflection laws. This first law will be here, angle of incidence is always equal to angle of reflection. Condition number 1. Condition number 2 will be I, R, N are lie in same plane. Incident ray, reflected ray, or normal, these three are available in a same plane. So this is a two condition, okay, of the reflection of light. Once again, so this is a mirror, this is smooth surface, they were coating on a backside with silver oxide. This is important bit, Ag2O. They will apply in backside coating, so then the light will be takes place in reflected in same medium. So this is a smooth surface, it will be, okay, reflected in a same medium back in bounds. So this is I, this is R, this is angle of I, this is of angle of R. So, okay, for what is the first condition of, okay, laws of reflection will be, first law will be angle of incidence is always takes place in angle of reflection. Condition number 1. Condition number 2, I, R, and R lie in same plane. Now here we can discuss in a high polished surface such as a mirror. So this is a mirror. This is a high polished surface such as a mirror. Yes, reflect most of light falling on it. So you are okay. Now here we can understand. We can see in daily life. So you are already familiar with the laws of reflection of light. There will be here two of laws of reflection. They will be here. First law will be the angle of incidence is always equal to angle of reflection. So this is first condition. This is a angle of incidence is always equal to angle of reflection. Condition number 1. Condition number 2, incident ray, reflected ray are normal. Okay, or lie in a same plane. Okay, they are the two types of laws we can applicable only for reflection of light. So in our daily life we can see in different type of situation we can use different type of mirrors we can use daily life. So these are, so in case of reflection takes place in mirrors. Reflection takes place in mirrors. So these mirrors are generally two types. First one is a plane mirror, second one is a curve mirror. Now discussing. So this reflection takes place in mirrors also. First one is a plane mirror. First one is a plane mirror. Second one is a curve mirrors. Second one is a curve mirrors. They will be further converted into two types. First one is a concave. Second one is a convex. Okay, curve mirrors are further divided into two parts. First part will be here concave mirror. Second one is a convex mirror. So generally, reflection takes place in mirrors. This is called smooth surface. They will be contained in two patterns also. First one is a plane mirror. Second one is a curve mirrors. Plane mirrors they contain this type of pattern also. This is plane mirror. This is plane mirror. If any object we will take in plane mirror, we can see. So this is object. This is image we can observe. Means here the distance. This is called as U. This is called as a V. U is here object distance from the mirror. So this is called as a H. So this is called as a H dash. So now discussing plane mirror, which takes place in different conditions we can observe in daily life also. First condition will be here. Okay, U equal to V. What is a V? Here second condition, H equal to H dash. H equal to H dash. Now here U is called as a object distance. U is called as a object distance from the mirror. From the mirror. V is called as a image distance from the mirror. Okay. H is called as a height of object. Now here H dash. Okay, H dash is called as a height of image. Now here H is called as a height of object, H dash is called as a height of image. Now U is called as a object distance, V is called as here image distance. U is called as a object distance, V is called as here image distance also. H is called as a height of object, H dash is called as a height of image. In case of plane mirror, we can observe. In case of plane mirror, we can observe the height of object and height of image both are same. This is simply called as a H equal to H dash. In case of plane mirror, we can observe in case of the object distance is always equal to image distance. As a U equal to V. U equal to V. Okay. Next here magnification M equal to minus V by U. That will be equal to H dash by H equal to always here So this is a condition. This is called magnification. Okay. Magnification of plane mirrors is always equal to 1. Means the height of image and object, the same way the distance of image and object both are equal. U equal to V, H equal to H dash. This is because as a magnification is always take place in plane mirror will be here 1. Magnification always 1 in plane mirror. So this is the conditions it takes place in plane mirrors. So plane mirror, we can observe the condition will be here. The height of image and height of object both are in same. The distance of object and distance of image will be here, both are same. U equal to V, H dash equal to H. So these are the two conditions it takes place in this pattern also. U equal to V, H equal to H dash. Same way, magnification formula minus V by U equal to H dash by H. So this will be always equal to 1 for plane mirrors. So these are the some properties takes place as a plane mirror also. Okay, now one more condition we will discuss in the plane mirror will be here. Plane mirror will be this is called as the image is formed as a image is formed only virtual image. Here in case of here plane mirror, we observe the image will be here virtual image. Virtual image is that image we cannot capture on a screen. This is called virtual image. Okay, now once again the virtual image that image we cannot capture on a screen is called virtual image. Now here plane mirror, in case of plane mirror we observe the image will be only for virtual image. So these are the three conditions takes place in a plane mirrors also. Once again, in case of plane mirror, the height of object and height of image will be same. Okay, the U and V also same. U is called as a object distance from the mirror, V is called as a image distance from the mirror. This will be always same. So U equal to V and H equal to H dash. Same way magnification will be always 1 for plane mirrors. Magnification formula M equal to minus V by U equal to H dash by H. This is always 1. So these are the three conditions takes place in plane mirror also. So these plane mirrors we can use as a different applications in daily life. Now discuss them. Now applications of plane mirror. We can use some applications in use daily life. First application, applications of plane mirror. First application will be here, we use in periscope. We use as a periscope. We use in periscope. Periscope is here this type of pattern. The light is fast service. So one of mirror is used as a, this is a plane mirror. So this place mirror, the angle will be here 45 degrees. This is also angle will be here 45 degrees. We use as a plane mirror of corners of the periscope. So this periscope, we use a plane mirror, the angle will be here 45 degrees. So this is one of application of periscope. We can use in submarines. This periscope we use in submarines. We can be used in submarines. We can see in some things we can observe in high level or low level also. Okay, so this is a periscope. We can use this pattern also, periscope. So periscope is, we use a mirror will be here, plane mirror. The angle of periscope here, the will be here 45 degrees, 45 degrees. This is 45 degrees. They can arrange, we can use as a periscope. We can observe the, okay, the internal and upper parts of the, if any material, we can easily learn. So this periscope is generally used in a, okay, submarines also. This is a first application. Second application we use as a kaleidoscope. Okay, kaleidoscope is a one of operator we use in the content. Okay, cylindrical shape. We can contain. We use a plane mirrors. The angle will be here. Okay, at approximately 60 degrees. So this is a one of the, okay, kaleidoscope we use in daily life. We use as a plane mirror. We use as a plane mirror. They contain, okay, cylindrical shape. We use as periscope. Okay, kaleidoscope. Kaleidoscope. We use a plane mirrors. The angle will be here 60 degrees. We can observe in different colors of, we use in this particle. In these particles of the, okay, the internal parts of the kaleidoscope we can use. If anything they will take to observe the kaleidoscope, we contain different colors also. This is a application of plane mirror. First application will be here periscope. Second application will be here kaleidoscope. Okay, third application we use as this is a, okay, multiple images. When two plane mirrors are, they can be designed in particular angle, they call as a, okay, inclined mirrors. So these inclined mirrors we can form as a multiple images. Okay, this is a one of application. Third application form as a multiple application. Multiple applications are simply called as a multiple images, or we observe in inclined mirrors. Okay, inclined mirrors are those mirrors we can be arranged in a particular angle in between two plane mirrors. This type of pattern also. This is one of mirror. This is one of mirror. This angle will be theta. Okay. Okay. Now here this two types of mirrors. These two plane mirrors we can be designed in the pattern of the different angle. So this angle between the two plane mirrors with theta. Now we can observe the multiple images formula n equal to 360 by theta minus 1 if n value is, okay, the n value is, okay, n value is a, okay, even number. Okay, if n value is odd number, the formula will be n equal to 360 by theta. So this is the answer. So this is a formula we use. They easily determine the, okay, number of multiple images. So this is called as a multiple images. So this image, this plane mirrors called as a inclined mirrors. Inclined mirrors we can see in daily life in different shops. Okay, cool drink shop, barber shop. We can use different angles of mirrors. They can arrange in different pattern. We can observe as a, okay, multiple images we can observe in daily life. If we can use the formula will be here n equal to n is called as a multiple images. Yeah, n is called as a multiple images. So n equal to 360 by theta minus 1 if n value is even. If n value is even, the formula will be 360 by theta minus 1. If n value is odd number, the value will be here 360 by theta. If we can observe, for example, theta will be taken as here 90 degrees, means two plane mirrors, they can they arrange in a pattern of both are, okay, perpendicular each other. Then the n value will be 360 by 90. Okay, the value will be here approximately 4. Approximately 4. So this is a 4 is a even number, to take minus 1. The value will be 3. So this is our answer. Now in this case we can observe the number of images will be 3. 3 images we can observe easily. When the two plane mirrors are arranged in a both are, okay, perpendicular each other, perpendicular to each other. So this type of pattern we can observe them. The number of images we can observe, the n equal to 360 by theta. Theta will be 90. Now we can observe the 360 by 94. 4 is a even number, so the formula will be 360 theta minus 1. So this is answer. So the number of images will be observed in 3 images. So this type of question asked as in our examination. Here the both plane mirrors are arranged in the angle of this pattern. Now we can see here, if n equal to 180 degrees means that both plane mirrors are arranged in this pattern also. Both are the parallel each other. Sorry, both are the adjacent angle 180 means they can be adjacent side by side. So this type of angle. This is one of plane mirror. This is one of plane mirrors. So this type of arrangement we can observe. Now n equal to theta equal 180. Now n equal to 360 by 180. The value will be 2. This is an odd number. Sorry, even number would take minus 1, option will be 1. So number of images, multiple images we observe only for one image will be observed in this pattern also. So we can observe only for one image. So this type of applications we use in daily life. In your examination, ask this type of questions. First application will be plane mirrors are used as, first application will be here periscope, second application will be here kaleidoscope, third application will be used in multiple images, like as we use in inclined mirrors. Inclined mirrors is those mirrors we can be arranged in particular angle in between them. So these mirrors is called as a inclined mirrors. So they form as a multiple images. Then the formula will be n equal to 360 by theta minus 1 if n value will be here even number. If n value will be for odd number, the use the formula 360 by theta. This is our condition. They form as a multiple images also. So this is a one of applications we use in daily life as a plane mirror also. Okay, these are the some type of applications of plane mirror, some type of properties of plane mirror. Now we discuss in curve mirrors. These curve mirrors are two types. They will be concave and convex also. Now discussing curve mirrors. Some type of properties they will be used in daily life. Some properties we can first discuss, and then some applications we can regard as a concave mirrors and convex mirrors we can discuss now. First we discuss in concave mirror. This is concave. This is a convex. Concave and convex. Okay, this contains this type of mirrors, concave. This type of mirrors, convex. This type of mirrors. So this is a normal. So this is a object. This is object. This is a reflect the form image. This is as a U. This is taken as a V. Same pattern also. This is a object. They form as a image. Okay, this is a image. Okay. Now this is a U. This is a V. U is a object distance. Okay, this is a U. This is a V. V is a image distance. U is a object distance. V is a image distance also. Now, in case of concave mirrors, they take place in in this type of mirror. Convex is type of this type of mirror. Generally, the concave mirror. Generally, the concave mirror takes place in the shape of this. Here we can see the other picture is this. Concave mirror, this form, this here. simply called as a concave is simply called as a converging mirror, and convex they take place generally in this type of pattern. This type is a diverging mirror. This simply called as a diverging mirror. Now here we can observe easily. Okay. Now some type of properties discuss now this pattern also. Now some type of properties we discuss in regard as a concave and convex also. Now first condition will be here, u is not equal to v. Same way, u is not equal to v. U means here object distance, v is called as a image distance. Same way here, concave or convex both are not equal to u equal to v. U is called as a object distance, v is called as a image distance. Condition number 1. Condition number 2, h is not equal to h dash. Same way here, h is not equal to h dash. But here, okay, h dash is more than h in this case. In this case, h dash is less than h also. Here, h dash is more than h. Here, h dash is less than h also. So this is a condition. This is a condition of here what is the h dash? Height of image. What is h? Height of object. Same way, now here height of image is more than height of object in case of concave. But in case of convex, the height of object, height of image is less than height of object also. In the same way, height of image is more than height of object. Here height of image is less than height of object also. So this is a quite reverse also. Third one is this is a real and inverted image they can form. Real and inverted image they can form. Real and inverted image. Real and inverted image is formed in case of concave mirror. In case of convex mirror, they form virtual image. Virtual and erect images form in case of convex mirror. Concave mirror, they always form generally real and inverted image. Real and inverted image. In case of convex, they form as a virtual and erect image. This is a condition number 3. Condition number 4, this is called as a converging mirror. Converging mirror. Converging mirror is called as a concave mirror. Concave mirror is a converging. In case of convex, it's simply called as a diverging mirror. Diverging mirror. This is a diverging mirror is a convex. Converging mirror is a concave. Concave mirror is called as a converging mirror. Okay, convex called as a diverging mirror. Diverging mirror. Now the formula of mirror formula same. 1 by f equal to 1 by v plus 1 by u. So this is a mirror formula, magnification formula minus v by u. Okay, that will be equal to h dash by h, same formula. Okay, formula of this. Now here f is called as a focal length, v is called as a image distance from the mirror, u is called as a object distance from the mirror. Here m is called as a magnification. that value will be approximately equal to minus v by u, that will be equal to h dash by h. Same formula here also, same. 1 by f equal to 1 by v plus 1 by u. This is a mirror formula. Or magnification m equal to minus v by u equal to h dash by h. Okay. In case of concave mirror, the magnification value will be here. Okay, here magnification will be here maximum value, maximum 1, more than 1 in the concave mirror. In case of this, magnification value is always less than 1. In case of convex mirror, magnification always less than 1. Magnification in concave mirror is always more than 1. So this is a conditions they will be. Okay. Here magnification more than 1 means the height of image is always more than the height of object in concave mirror. But in case of convex mirror, the height of object height of image is always less than the height of object. So this is magnification less than 1. This is magnification is more than 1 also. So this is the conditions takes place in concave and convex also. Concave and convex also. So concave mirror, the image will be formed as a magnifying image, means the image will form as a larger image. This is called as a enlarge of image. Rear inverted image and enlarge. Enlarged image, rear inverted and enlarged images form. Images form as a enlarge. Now here the form as a image form as a image is a diminish. Diminished images form in case of convex mirror also. So convex mirror, the image form as here diminished. They will be observed small size as the size of the object also. So here convex mirror we can use in different applications in daily life. They use as a rear view mirror. The simple called as a convex mirror is used as convex mirror. This is used as applications. Okay, used as convex mirror is used as a rear view mirror. Rear view mirror or side mirror. Side mirror in vehicles. Concave mirror, because the content size will be diminished, the image we can observe in the very closer than the object also. The long object we can available, the image will see in the very shorter. The size will be here very short. Size will be here shorter, but they can contain very close to each other. So this convex mirror we can use as a rear view mirror or side mirror of vehicles. Concave mirrors, the main application will be here rear view mirror or simply called as a side mirror. First one is this. Second application we use as a security mirrors. Security mirrors are simply called as a security mirrors are simply called as a security mirrors. Security mirrors. So security mirrors we can use in the shopping malls and many other conditions we can use security mirrors. The object we can be appear as very small size. Security mirrors. Security mirrors. Third one is these mirrors we can use as a roadside. Road corners we can use as a mirrors. Road corners. Road corner side we can use. Road corners is we can use in corners of we can go to way of the corners we can put one of image mirror we can see in coming from another side also. Road corner sides corners because for viewing coming from objects is any other direction also. So these mirrors we can use as Concave mirror we can use it as here, we can applications here. First one, concave mirror is used as first one is a ENT doctors. Second one is a dentist. Okay, dentist we can use. Third one is a solar panel, solar cooker. Okay, simple we use solar cooker. Simple called as a solar dish. Fourth one called as a torch light. Torch light we can use as a different applications of concave mirrors also. Concave mirrors is used as a ENT doctors, dentist, solar cooker, solar dish, okay, or okay, torch light we can use as a concave mirror also. Convex mirror we can use in simple called as a rear view mirror, simple called as a side mirror of vehicles, security mirrors, and also road corner side we can use as mirrors. This mirror called as a convex mirrors. So these are the some applications of based upon this also. Okay, in exam point of view, some type of questions regard us ask this one as a some type of question also. So they contain some type of conditions they regard as a okay position of object, position of image. They will change. They will be changed. Some type of conditions we can pass. Examination ask as a different type of pattern. We ask us this the position of object is changed. The position of image will be changed. Then the size of nature of image, size of image. They will contain different patterns also. Now discussing some type of conditions regard as a concave mirrors. Image formation of concave mirror. Different position of the object. We discussed some conditions. In examination, ask as a different pattern questions regard as a these conditions also. Now first of all discussing okay different type of okay conditions regard as a formation of image of concave mirror and also convex mirrors. First of all we discuss in concave mirror okay positions. Image formation of a concave mirror at different positions of objects.